If you talk about a line, lines can be steep or flat. You can be really super steep or really super flat. It's called the slope. And if you think about like a slope is a mountain, and mountains have steepness, so it's the same kind of term. It's represented by the letter M, and you might go, why is slope M? That makes no sense, but that's because it's magnitude. That's where the M comes from. Well, M is slope, but the M comes from the word magnitude. Now, the way you calculate slope is we're looking for how far up or down do you go versus how far over do you go. So it's rise over run, and to remember that, you have to get up before you can go running, right? So you have to rise before you can run. Okay, so the rise, the up and down, has to go on top of the sideways. It's the change in y, so how much y changes divided by how much x changes. So if we have 2 points, if this is a point here, yeah, so, and it doesn't matter, it can be y1 minus y2, y2 minus y1, that doesn't matter as long as it's, if you do the first minus the second in the top, it has to be the first minus the second in the bottom. They have to go in the same order. That's the only thing that matters. So you subtract 1 point from the other. Also, you might see it symbolized like this. In math, this is the symbol, it's the Greek letter delta, and it means change. We can have what's called the slope-intercept form of an equation, and when you talk about the slope-intercept form of equation, that's y equals mx plus b. You remember that from algebra? Where m is the slope and b is the y-intercept. Okay, intercept. So m is how much it's moving, and b is where it hits the y-axis. Yeah. Yeah, so b is where you start. Like, I like to consider this the starting point, and then these are the directions. Okay, to put things into y equals mx plus b, we're going to rearrange a formula. Okay, I'm going to take this x, and I'm going to move it over here. I like to just pick them up and move them, so if I change the side, I change the sign. Right, because you can't switch teams and wear the same jersey. Okay, so if you pick him up and put him on the other side, you got to change him. So the next thing we want to do is we're going to divide by -4 because we want y to be by itself. So I get y is equal to, well, -2 over -4 is positive 1/2 x, and positive 7 over -4 gives me a negative number, and I'm just going to leave it 7 over 4. You don't have to do anything with that, just leave it. It's fine. So we've got it into this format, we can identify that the slope is 1/2, and then the y-intercept would be -7/4. So it would hit the y-axis at -7/4. All right. Horizontal lines have a slope of 0. So if you're completely flat, your slope is 0 because your rise is 0, right? And your run is, well, whatever, infinite, really. And you can divide 0. 0 divided by 5 is 0. 0 divided by 20 is 0. 0 divided by 10 million, 0. No problem. But when you have a vertical slope, it's undefined because your run is 0. And you can't divide by 0. Yeah, so what you would have here is you would have rise is really infinity, and so you'd have infinity divided by 0, but you can't divide by 0 because... Did anybody ever explain why you can't divide by 0? Ah, well, here, let me explain that. Okay, if I do 6 divided by 3, that equals 2, correct? You all agree? That also means that 3 times 2 equals 6. If I divide by 0, what times 0 equals 6? Nothing, right? Nothing exists that I can multiply 0 times this thing and get 6. So there's nothing here. So it's undefined. You can't do it. It's impossible. So that's why a vertical line, so this vertical line, M, is undefined. And for the horizontal line, because it's flat and we can divide 0 by everything, M equals 0. Slope formula is subtract the y's, subtract the x's, and divide it if you can. So we have to assign one of these points as x1, y1, and x2, y2. Do you want this to be x1 or this to be x1? 5 or 7? Okay. So that's x1, y1. This is x2, y2. So my slope is going to be -9 minus -1. So don't forget it's minus, and then this was already negative. So it's minus a negative over 7 minus 5.
So you do 5 minus -1? Or, I mean...
9 minus -1. Yeah. And so negative minus a negative is a positive. He's a little happy man. So that's -9 plus 1. So -8. And 7 minus 5 is 2. So I can divide that, so it's -4.
That's it?
Mm-hmm. Now, I should probably go over this. Positive slope, the lines move up as you move from, like the direction you'd read. So from left to right, the line moves up. If your slope is negative, your line moves down. So this line would be moving down. Also, the larger the number, the steeper the slope. Okay, let's do the next one. And just to change things up, I'll make those 2 and this one 1. Because it really honestly doesn't matter. So I'm going to do 5 minus -7 over 6 minus 3. Minus a negative is a positive. So it's 5 plus 7, so that's 12 over 3. So that is +4. Okay, so we have a point 1, -2, and x 11, -11. And we have our slope. This is m. But we don't have this x. So I can call this x1, y1, x2, y2. And I'm going to plug in everything I have. I have the slope. I have -2. Oops, I wrote that backwards. Sorry. I have -11 minus -2 over x minus 1. Now, did anybody ever show you this trick? If I have, let's say 5 is equal to 10 over x. If I have a variable in the denominator and it's equal to a single number over here, I can take what's in this denominator, I can take what's here, and I can switch them, and x is equal to 10 over 5. If you have a variable in the denominator and just a single number over here, you can take whatever's in this denominator and this number and you can switch them. Here's why. Because if I have 5 is equal to 10 over x, just for my example, well, to get rid of that x, I'd multiply by x. So I would get 5x is equal to 10, and then I would divide by 5, and so I would get x is equal to 10 divided by 5. So see how they just switch places? So you don't have to do all of this if you learn the trick. Now, it's specific. There can only be just a single number over here. Okay, you can't have anything else going on. It has to be just a single number. But I can take this whole x minus 1 and this negative 3 and I can switch them. So I get x minus 1 is equal to, well, okay, negative 11 plus 2 is negative 9 over negative 3. So x minus 1 is equal to positive 3. So far, okay?
Is this another problem?
This is this problem.
Oh, it's still the same problem?
Yeah, I just took the negative 11 and I plus 2 to give me the negative 9.
Okay.
And then I switched these to give me that negative 3 there. Negative 9 divided by negative 3 is positive 3. Add 1 to both sides. And x equals 4. Do you want to see another one like that? So, all right, so we have our, we can say this is x2, y2, x1, y1. It doesn't matter. And I'm going to do so I'm going to plug in what I have. M is negative 9. Y2 is negative 6. Y1 is negative 12, or minus positive 12. X2 is x minus x1, which is 5. Okay. I think it'll make more sense if I do this in another step. So negative 6 minus 12 is negative 18 over x minus 5. I'm going to take these two things and I'm going to trade them. And that's going to give me x minus 5 is equal to negative 18 over negative 9. So that's x minus 5 is equal to positive 2. Negative divided by negative. Add 5 to both sides. X equals 7. So I'm going to divide by 2, so I'm going to get y equals negative 1/2 x, oops, I forgot to divide by 2, plus 1. B, this is my y-intercept. This is where I start. So my first line is going to start right here on the 1. My slope is negative 1/2. Okay? Now, if your slope is negative, go down and then right. If your slope is positive, you go up and then right. Because I'm negative, I'm going to go down 1 over 2. Down 1 over 2, down 1 over 2, etc. until you have enough points to draw a nice pretty line.
So if it's positive or negative, they're both right?
Yeah, that way you don't have to remember. If you always go down first or up first, it's easy to remember. Negative is down, positive is up. If you always go to the right, it'll always work that way.
Okay.
Because if you wanted to go up first here, you'd have to go to the left. But then it's kind of hard to remember that. So it's easier to just think up and down as your positive and negative if you always go to the right. Okay, then I'm going to draw my line. And it's going to be nice and pretty. There's my first line. Okay, now for my second equation, I've already got it into y equals mx plus b. If it's a whole number,
So just go down 1, then right 2.
Yeah, I went down 1 and then right 2. If you have a whole number, put a 1 on the bottom of it. That's how many you go over. So this is positive 2 over 1, so I'm going to go up 2 over 1.
Okay, so I did that first, I go down 3.
I start at negative 3, so I'm going to go 1, 2, 3.
That's the y-intercept.
Yeah, that's the y-intercept. The 1, LaTroy, I just put, if there's a whole number, put a 1 underneath it, because 2 over 1 is the same as 2, and that tells you how many to go over. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, and you can just do as many as you need to do. until you get enough points to make a nice, pretty line. And if your lines aren't that pretty, that's okay. Yeah, it's easier if you use different colors.
When you did the up to over 1, you started at 0?
No, I started at -3. This is, you always start at the B. Yeah, with the number not attached to the X is your starting point, and then the slope is your directions to go from there.
Yeah.
So the -3 was down?
Yeah, -3 is here.
Got it.
Okay, here, I don't have anything, so that's the same thing as saying +0. If I don't have anything that's like +0, I should change the color on that. Let's use, do you guys want to use green or pink? Pink? Okay, pink. We're using pink. It's a purpley pink. Yeah, it's a compromise. It's purpley pink. Okay, so if there's nothing there, it's the same as +0, so we're going to start at 0. And then our slope is -1/2, which was the same as our first slope, so we're going to go down 1, over 2, down 1, over 2, down 1, over 2. Keep going, and then I'm going to go back to the pink, and I'm going to make a nice, pretty pink line, and you'll notice something. They don't, the pink and the blue don't, right?
Oh, they're parallel.
Yeah, the pink and the blue are parallel. They don't intersect. But the black one, if you look at this angle, what does that angle look like it ought to be?
Right?
Yeah, a right angle. Now, it's probably not exact because we're drawing it and we're not exact. But if we drew it perfectly, it would be a right angle. It's perpendicular. Look at the slope. We have our first slope is -1/2 and our second slope is +2. And these two slopes are perpendicular to each other. Opposite reciprocals. And then we had our third slope was also -1/2, and these two are parallel to each other. Parallel lines have the same slope. And perpendicular lines have opposite reciprocals. Parallel lines lie in the same plane but never intersect. They have identical slopes and different y-intercepts. Our slope for one was -1/2, and here it was -1/2, right? But here my intercept was 1, and here my intercept was 0. So same slope, different intercepts. They're parallel. Perpendicular lines are negative reciprocals, so m equals 2. So if I have, let's just say some slope is a over b. The perpendicular slope to that would be, perpendicular slope would be -b over a. So it's opposite and upside down. For perpendicular. So technically these are negative reciprocals, if you want to talk about them in math terms. Okay, so opposite and upside down are perpendicular. Whereas if you have regular, m will be parallel to itself. Like, so if you have the same slope, you're parallel. If you're opposite and upside down, you're perpendicular. And if you're anything else, you're just intersecting. Now you can have, with the perpendicular lines, you could have the same y-intercept. Like I could go through 0 and be perpendicular, so that the y-intercepts don't have anything to do with perpendicularity. And just as a side note, if your m's are the same and y is the same, or not y, sorry, b. Okay, so if you have the same slope and the same y-intercept, you are the same line. Not parallel, you're just the same. Slope of -5. What is our parallel slope? They're the same, negative 5. So parallel is the same. Now, reciprocal of 5 is, anybody remember? 1/5. Because if you have a whole number, so the reciprocal of 2 is 1/2, the reciprocal of 3 is 1/3, 4 is 1/4. So the reciprocal of 5 is 1/5. It's negative, so perpendicular will be positive. Okay, if I have a slope that's a fraction, let's say I have a slope that is 2/3. My parallel slope will also be 2/3, and my perpendicular slope will be negative 3/2. So if you start positive, your perpendicular is negative. If you start negative, your perpendicular is positive, and you flip. So let's find the slope of the line parallel to this line. So the first thing we have to do is find that slope. So I'm going to pick up this x, and I'm going to move it over here, and so I changed sides, so it becomes negative. Then I'm going to divide by 3. So here's my slope. Okay, so what's my parallel slope? Same thing, yeah, negative 2/3. If I did my perpendicular slope, though, it would be 3/2.